Hi, welcome to Chapter 4, Section 4, using the quadratic formula. So the quadratic formula is something that you can always use to solve a quadratic. It always works. Okay, that second bullet point says a formula that always works, that can find the solutions to a quadratic equation, is called the quadratic formula. The standard form of a quadratic equation in one variable is ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. So you've seen that, I think, 3 times now. Okay, it hasn't changed. We always have ax squared plus bx plus c. And if you use the quadratic formula, the standard form is very important. It has to equal 0. So this is the quadratic formula. Let a, b, and c be real numbers such that a does not equal 0. The solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we are going to use that every time in this worksheet, in this set of notes, in this section. We're always going to use quadratic formula. But if I'm giving you the option, this works every time. Every single time. It'll always give you an answer. It might not be the easiest way to go about it, but if you're very comfortable with it, I suggest you learn it and get used to it, because it never fails. It's like the way that we factor the long way around. You know, it never fails, as long as it's factorable. So, for example, one of the stipulations for using this formula is that it has to equal 0. This does not equal 0. There's a 10 on the right side, and a 3x squared plus 4x on the left side. So the easiest thing to move would be the 10, and we're going to move it by subtracting. So we get 3x squared plus 4x minus 10 equals 0. So what I like to do, just so that I have everything set up beforehand, is write down my a, b, and c. So our a is 3, our b is 4, and our c is negative 10. So make sure you get all of the signs right and write them to the side, so that when we go to plug it into our quadratic formula, we know exactly what is what. You don't have to look at the equation anymore. You just look at what you just wrote down. So before you start using the quadratic formula every time, I want you to write down what the quadratic formula actually is. X equals negative b plus or minus the square root b squared minus 4ac over 2a. We're going to replace every letter with the number that goes in that spot. And every time, we're going to put everything in parentheses. And we put it in parentheses because if you put it in your calculator without parentheses, it could give you the wrong answer. So it's very important to put everything in parentheses. So x equals negative b. Well, our b is 4. So in parentheses, we put 4. Plus or minus the square root of b squared. Well, our b is 4. Minus 4 times our a, which was 3, and times our c, which was negative 10. Over 2 times our a, which was 3. So we filled it in. Everything's in the right spot. Now we can simplify, right? We have to do the little math first. So a negative times 4 is negative 4. 4 squared is 16. Negative 4 times 3 times negative 10 is positive 120. So we're going to go ahead and change that. And 2 times 3 is 6. Now, do you have to do all of these in this order? No, you can do more at once if you want, but you cannot plug the whole thing into your calculator at the same time. It will not give you the right answer. It'll give you a decimal, which will be wrong. So don't just plug everything into your calculator. It won't come out right. So let's combine what's under our radical. 16 and 120 is 136. So as of right now, there's nothing we can do except simplify our radical. So we need to come over here to the side and determine what that radical should be simplified. So we have 136. The smallest thing 136 is divisible by is 2. You get 68. That's divisible by 2 to get 34. That's also divisible by 2 to get 17. Now 17 is a prime number, so we're done. So when we look at our radical, we have a 2 times 2 times 2 times 17. And remember, you can only take out pairs, so we'll take out this one pair. We get 2 times the square root of 2 times 17. So let's go ahead and multiply those back together to get 34. Alright, so now we can take that and replace the square root of 136. So we have x equals negative 4 plus or minus whatever our thing was, which was 2 square root of 34 over 6. Now there is one more thing that we can do, because this can be simplified a little bit more. The 4, the 2, and the 6 all have something in common. They're all divisible by 2. So divide that 2 out. So negative 4 divided by 2 is negative 2. 2 divided by 2 is 1, so we're left with the square root of 34. And 6 divided by 2 is 3. So this is our final answer. Now if you put that into a calculator, it would come out with a very ugly decimal, which is why we cannot put it into our calculator to begin with. Let's do that again. 2 more times. Okay, so with example 2, we have 2 things on the right-hand side and 2 things on the left-hand side. So let's move it to the left. Okay, well, to get rid of a negative 13x, you add 13x. So we add 13x to both sides. And to get rid of a negative 16, you add 16. So we will also add 16 to both sides, so that this now equals 0. We have 4x squared plus 16x plus 16. And there you go. So our A, let's come over here and write our A. Our A is 4, our B is 16, and our C is 16. Remember, you start out by writing the quadratic formula, so x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you take your letters and replace them with your numbers. So we have negative in parentheses 16 plus or minus the square root of in parentheses 16 squared minus 4 times 16. All over 2 times 4. Okay, so we replaced our letters with numbers. Now we simplify. Well, negative 16 is just negative 16. 16 squared is 256. Negative 4 times 16 is negative 256. And then 2 times 4 is 8. Okay, well, that means that we have negative 16 plus or minus the square root of 0. Well, the square root of 0 is just 0, so that goes away. So we get negative 16 over 8, and negative 16 over 8 is negative 2. So our final answer is negative 2. So if the square root goes away, you don't have to worry about simplifying that because it's just gone. And that happens. Let's do it one more time with the quadratic formula. Okay, so again, we have 5x squared plus 2x equals negative 1. Well, that negative 1 needs to move to the other side because it has to equal 0. So let's add 1 to both sides. Now remember, whenever you have unlike terms, and I should have said this to begin with, you cannot combine them. So you just put them next to each other like we have done in the past. And now let's write our A, B, and C. So our A is 5, our B is 2, and our C is 1. So now we write our quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Then we replace things. So we have negative b, which was 2, plus or minus the square root of 2 squared minus 4 times 5 times 1 all over 2 times 5. So x equals negative 2 plus or minus the square root. 2 squared is 4. Negative 4 times 5 times 1 is negative 20. And 2 times 5 is 10. So we simplify what's under the radical. And we get 4 minus 20 is negative 16 over 10. Now remember, when you take the square root of a negative number, you always, always, always pull out an I. There's always going to be an I in your answer. And then you can think, well, what's the square root of 16? Well, the square root of 16 is 4. So we have 4i. The 4 takes care of the 16. The I takes care of the negative 1. And then over 10. But just like in example 1, if you look here, we have a 2, a 4, and a 10. And 2, 4, and 10 are all divisible by 2. So we're going to divide them by 2. Negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. And 10 divided by 2 is 5. So this is our final answer. And that's how you use the quadratic formula. So we will practice this more in class. Now, in the quadratic formula, the expression b squared minus 4ac, the part that's underneath the square root, as you can see right here, is called the discriminant. And the discriminant can determine what kind of answer you're going to get. And we have proof of that. So if you have b squared minus 4ac greater than 0, like in this first column, that means a positive number. Okay, that just means a positive number. Then you're going to get two real solutions. So if you look back at example 1, in example 1, under our radical we had a positive 136. Well, because it was a positive 136, it was greater than 1, and we ended up with two real solutions. Now, they weren't rational because of the square root, but they were real. They were not imaginary, and there were two of them because you have the positive and the negative. If you have it equal to 0, then you will have one real solution. And that's true in example 2. In example 2, under the radical, we ended up with 0. And that's what it's talking about, that part under the radical. So when we solved it, we had negative 16 over 8, which gave us negative 2. That was one number. There's no plus or minus. It was just negative 2. That's one real solution. And then for two imaginary solutions, if it's less than 0, because a negative under the radical means you have to take out that I. So if you look at the example we just did, we have the square root of negative 16, which gave us 4i, which is an imaginary solution. So this trend works, and you can see that in all of the problems that you just did with me. Now these are what the graphs look like. For two real solutions, it crosses twice. For one real solution, it touches and comes back up. And for no solutions, no real solutions, the imaginary solutions, it never touches the x-axis because there's not an actual solution. There's not a real solution. It's imaginary. So we need to make sure that you are able to figure this out just by using the discriminant. So in example 4, it asks you to find the discriminant and describe the number and type of solutions of the equation. So the first thing I want you to do is the same thing we did before. You're going to write your A, B, and C. Well, in A, our A is 25, our B is negative 20, and our C is 4. Make sure you're paying attention to the signs because the signs make all the difference in the world. Now we're going to write the formula that we need, and we don't need the whole thing, we just need the b squared minus 4ac. So let's plug everything in. B squared, so negative 20 squared, notice I put everything in parentheses still, it's a good habit to get into, minus 4 times 25 times 4. Well, if you were to put that in your calculator, you'd get negative 20 squared is 400. And negative 4 times 25 times 4 is also 400. And that equals 0. Well, what happens whenever b squared minus 4ac equals 0? You get one real solution, and that is the answer. So one real solution. And that's what we needed. Let's do that again. So for b, let's write down our letters. We have A, B, and C. A is 1, because remember, if there's nothing written in front, it's just a 1. B is 2, and C is 6. So we have b squared minus 4ac. That's what we're filling in. So 2 in parentheses squared minus 4 times 1 times 6. Well, 2 squared is 4. And 4 times 1 times 6 is 24, which is negative 20. All right. Well, my answer is negative. Well, where is it negative? That means that b squared minus 4ac is less than 0. So we're going to have two imaginary solutions. So two imaginary solutions. And there you go. Last one, C. Well, we have to write down our A, B, and C. 1 is A, B is 2, and C is negative 3. So we're filling in b squared minus 4ac again. So b is 2, in parentheses squared, minus 4 times 1 times negative 3. So 2 squared is 4. Negative 4 times 1 times negative 3 is positive 12. And 12 plus 4 is 16. Well, 16 is greater than 1. It's not equal to 1, and it's not less than, it's greater than 0. It's not equal to 0, and it's not less than 0. So we're looking at this first type of answer, which means that we have two real solutions. So the answer is two real solutions. And that is it. Please be ready next class to come in and start working immediately on quadratic formula.